Hi, hello and welcome to this video. This video covers the topic modules, characteristics of modules, benefits of using modular programming and access control. So these are the topics that we are going to see. In the previous video, we saw built-in functions in types of various scopes. There, we saw that built-in functions are also called as modules. So in short, we can say that modules are also functions. Hope you remember in 11th C++ we saw the definition of function as a large program can typically be split into small subprograms called as functions, where each subprograms can perform some specific functionality. Here in this definition it is said that small subprograms are called as functions. The large programs are made up of small subprograms. These subprograms will perform some specific functionality. What does this specific functionality mean? It holds the coding to do some logical operations like addition, subtraction, multiplication, factorial, to find even or odd numbers, etc. So likewise, any such logical coding can be written and saved as functions with a particular name. Whenever we need these codings in program, we can just call these function name. So code reusability is possible in functions. Now let's come to our topic, modules. What all we said for function is applicable to modules too. In our program, the definition for module is given as a module is a part of a program. Then we can say that a part of a program are nothing but the subprograms. Then the next line in book is programs are composed of one or more independently developed modules. We can say that one module and another module inside a program have no connection. They can work separately, that's why given independently developed modules. And when 2 or 3 modules are written, each module can work separately without having a link to each other. So that's why it's given independently developed modules. Inside a module, that is, a single module can contain one or several statements closely related to each other. This statement means that the statements inside the modules are closely related to each other. Similar type of logical statements are written inside a module. For example, if you are writing a program to find a number is even or odd, each statement in the program will be related to the logical statement n modulus 2 is equal to 0. That is, if a number n is divided by 2, and if we get the remainder as 0, then that number is an even number. So all the statements are related to this logic. That's why it is said that closely related to each other. Modules work perfectly on individual level and can be integrated with other modules. This statement means that modules can be called and used separately, or it can be used inside another function. So this concept is called nested function. That's what integrated means here. So we can use a module separately, or if we want, we can use it inside another module also. So that's what it's given as integrated with other modules. Now let's see the next statement. A software program can be divided into modules to ease the job of programming and debugging as well. This statement means that a software program is made up of different modules. So different types of modules under different name can be created, and these modules are written separately and they are debugged separately. Debug is nothing but finding errors. If any errors are there, they are corrected and they try to execute it. If we take the example of a game, the background is designed and coded separately. So this background designing is done by a separate person. The character that appears are created separately. The characters that are used in the games are designed separately by a designer. The action that the characters perform are coded separately. All these are debugged separately and checked. So all these codings, that is the actions that the characters do, each actions are coded separately by separate programmers. All these are debugged separately and checked. Finally, they are all combined together as a single game software. This is what given in book as a definition for modular programming. A program can be divided into small functional modules that work together to get the output. They are created separately and combined to get us a complete software. The process of subdividing a computer program into separate subprograms is called modular programming. So modular programming, this is the definition for modular programming. So in a program, it is divided into small modules, and each modules are coded separately and they are debugged separately, and this concept is called modular programming. Modular programming enables programmer to divide up the work and debug pieces of program independently. The same point is said here also. The modular programming helps the programmer to write the coding separately and check the coding separately for any error. These codings are written and debugged independently. The examples of modules are procedures, subroutines, and functions. Procedure, subroutine, function, modules are all the same. All of them have the same concept. They are all subprograms. So this is about introduction to modules. Now let's see the characteristics of modules. In this book, given 5 points. Let's see them one by one. The first point is modules contain instruction, processing logic, and data. Here, instructions are nothing but the statements that are written. Let's see an example program in C++. Here we have written a small module called, the name of the module is add. In it, we are using 3 variables, a is equal to 10, b is equal to 15, and a variable c, which are all have integer data type, int. So the next statement, c is equal to a plus b. And next statement, we are printing the value of the added number c. Cout is equal to c, equal to, it's written in double quotes, and the value for c is printed. Here we have 3 statements. These 3 statements are called instructions. The processing logic is the statement that holds the purpose of the module. That is, here c is equal to a plus b is the logical statement which tells the compiler to add the value in the variable and store it in the variable c. This statement is called processing logic. The last one is data. Data can be input value and the output values. Here the inputs are the variables a, b, and c, which holds the value 10 and 15. The output is 25, which is got by adding a and b. This 25 is printed using cout statement. So this is what said in the first point. Modules contain instructions, processing logic, and data. So to consider as a modular programming, a module should contain instructions, processing logic, and data. Now let's see the second point. Modules can be separately compiled and stored in library. As said earlier, modules are written separately and they are compiled separately. If it is executed successfully, the modules are stored inside library as a library file. For example, in C++ we use sine, cos, tan, strlen, that is string length, strcpy, that is string copy, etc. functions. Such functions are stored inside library under header files, math.h and string.h. If we want to use these library files in our program, concerned header files are included to our programs. So these functions such as the sine, cos, tan, string length, string copy, all these functions are compiled separately and they are stored in the library. And so whenever we need those functions, we can use it in our program using the header files. So this is the second point. Now let's see the third point. Modules can be included in a program. We saw this already. Modules are written and joined together to form a big program. Now the fourth point. Module segments can be used by invoking a name and some parameters. We know that when a function is called, it will have function name, that is the name of which function to be called, and the variables as arguments, and that's what it's given as. Module segments can be invoked. Here invoking means calling the functions. So the function is called using a name, and along with the function we use the arguments, and these arguments are called as parameters here. So this is the fourth point. Now let's see the fifth point. Module segments can be used by other modules. Here the concept said is nested function. A module can be used inside another function. So these are the 5 points which comes under characteristics of modules. Now let's see the next topic. So here we are going to see about benefits of using modular programming. If modular programming is used in a program, the following benefits are seen. Let's see them. The first one is less code to be written. If we want few codings to be repeated many times, such codings are written as a module. Whenever we need it, we can reuse them. For example, in few games, mostly running, shooting, jumping actions will be there. So such actions are written and saved under separate name. Whenever we want these actions to be included in game, just the name of the actions are called in the function. This way the size of the program can be reduced. So less code is written. So this is the first benefit. Now let's see the second benefit. A single procedure can be developed for reuse, eliminating the need to retype the code many times. Here it is said that once a module is written and saved, it can be used as many times we need in a program. Just think in a game how many times you press the shooting key or jump key or make the character to run. So here we have written the coding for it only once. But whenever the particular key is pressed, that function or module will be called and executed automatically. So here the code is reused without rewriting the code each time. So this is the second point. So without retyping the same code again and again, we are reusing the module that we have written once. Now let's see the third point. Programs can be designed more easily because a small team deals with only a small part of the entire code. In modular programming, where programs are written as separate modules, it is easy to design because these modules are handled separately by separate programmers. So each programmer concentrates only their modules alone instead of whole program. So this is the third point or the third benefit. Now the fourth benefit is modular programming allows many programmers to collaborate on the same application. The same point is given here. In modular programming, many programmers are joined together and work to develop it as a single application. If we take the WhatsApp, the codings are split to many programmers. When any error occurs in the software, that particular part programmer will rectify the problem. So many programmers work together for a single applications. So modular programming helps programmers to work together in unity and develop a single application. So this is the fourth benefit. Now we see the fifth benefit. The code is stored across multiple files. As we said earlier, modules are stored separately under a name. So each modules are stored as separate files. So a program can have many files. Now let's see the sixth benefit. Code is short, simple and easy to understand. As big programs are split as separate modules, the program size gets reduced and they are easy to understand and even easy to handle. So it is very easy to handle errors also. That's what given as next point, the seventh benefit. Errors can easily be identified as they are localized to a subroutine or function. If error occurs, they can be identified easily under which module error occurred, and it is easy to rectify in that module itself. Now the eighth benefit. The same code can be used in many applications. We know that Facebook and Instagram come under same owner. So if any common updates are to be made for both applications, then this modular programming helps us to do. So same updates can be used in both the applications. So this is given as the 8th point. Now the 9th benefit, the scoping of variables can easily be controlled. The scope of variable, that is local scope, global scope, enclosed scope and built-in scope, can be controlled easily in modular programming. So these are the 9 benefits of modular programming. Now let's see access control. Before going into further, just think, what does the access control mean? Just think of the word access and control and combine the two words access control. It just means controlling the access in modular programming for security purposes. In short to tell, it is access rights. Now let's see what's given in our book. Access control is a security technique that regulates who or what can view or use resource in a computing environment. We can relate the security techniques to OOPS concept in C++. That is the data abstraction, encapsulation, inheritance, polymorphism, etc. If we want to restrict the access of few parts of a program, we can do it using data abstraction. That is, we can show only the essential part and hide the rest of the program. This can be done through access modifiers. Do you remember these access modifiers? Can you tell what all access modifiers are there? The access modifiers are public, private and protected. Hope you remember that we studied in 11th under class. So let's recall these concepts. Public. So the public modifier. When a member of a class is declared as public, then they can be accessed from outside the class using the object of that class. Next, private. When a member is declared as private, then such members cannot be accessed directly from outside the class. They can be accessible only within the class. Next is protected. This protected access modifier is used while inheriting a class. Protected members can be accessed within the class and also by its subclasses. No other class can access protected members. You may think why we are studying this access control here. This is because in upcoming chapters, we are going to see the programming language called Python. In Python, the access specifiers are not used, but still it has the options of using the access specifiers by single or double underscore. In Python, the default access specifier is public, whereas in C++ and Java, it is private. As by default it is public in Python, any members can be accessed from outside the class, which is not possible in C++ and Java. So, through this video, we have completed Chapter 3 Scoping and we have already studied Chapter 4 Algorithmic Strategies. So, through this video, we are completing Unit 1 Problem Solving Techniques. In next video, we shall start Unit 2 Core Python's Chapter 5 Python, Variable and Operators. So till then, bye and thank you.